Today we'll be talking about gas plumbing. We are gradually coming to the end of our course, and this is week 10 out of 12. I hope you've been able to gain something, able to learn, right? And luckily, these videos are available so that I can always go back and rewatch, right? So yeah, moving on. We'll be talking about gas plumbing today. Is this system design is one of those ones where small mistakes create big mistakes. Sorry, small mistakes create big risks, right? So, I mean, without much explanation, it's self-explanatory, right? All those fire alarm system, fire sprinkler system that we designed before. If we if we want to test our system, we should design poor gas system, and then we'll know whether our system is really working or not, right? On a lighter note, right? So the codes are strict and the calculations must be accurate, right? So gas piping is still under gas plumbing. Is a distribution network, yeah, that must deliver the right flow rate to every appliance while staying within allowable pressure drop and limits, right? So this is very much like plumbing, right? That's why it's called plumbing after all. This is like water, freshwater plumbing or water plumbing, right? There's the cold water line coming from city. So they also have like a utility service, which is like basically the city's network or the city's what the city or the state how they supply gas, right? They could also be from a tank, right? Tank is like having a storage system, right? Where you just come and fill it up, and then um I mean over like maybe regular periods of time depending on usage, right? So it's very much like water supply systems, right? In because you hear things like flow rates and pressure drop, because gas is still like a fluid flowing through, and it must flow under the right pressure and volume to supply the necessary appliances, right? So another thing that the main components of a gas system, it could be more, but these are like some of the basic ones or the major ones, right? Basic, that's the better word. The meter, just like in plumbing, right? To meter the what is flowing through it, to like calculate, not calculate, to count, as the name implies, meter, right? It counts, because the whole point of utility service is that at the end of every month or at the end of every serviceable period, they bring a bill, right? So the meter is for them to be able to calculate based on the volume or based on the amount quantity of gas has been used, right? That's what the meter does, right? Then the regulator is almost like meter, but it is more it is meter cannot be tampered with, right? But regulator can be controlled like a valve, right? It can be controlled to like maybe if the gas demand is quite high, it can be regulated. Then if it drops, because definitely it might fluctuate with time, so regulator is there to help to regulate the flow, right? To permit from the lowest possible to the highest possible amount. Then we have the main distribution pipe, just like our water supply, right? So we have the main pipe and then the branches off of it. We also have branch lines, as I just said. Then let's talk about shut off valves. Now this is like a safety measure, right? So normally if there's need to, even in plumbing, if like water supply, if there's need to like maybe perform maintenance or any particular appliance, they will have to shut off the water supply, right? Same also they need to shut off the gas supply if there's need for like if there's an emergency or if there's need to like perform any kind of maintenance, right? So you shut it off so that it doesn't like leak, right? Another thing is the appliance connector. So after we for each of the branches, we have the connectors. I mean, each branch is so that it's going to a particular appliance. So how do you connect it to the appliance, right? So next, talk about the goal of this design is to deliver correct flow, that is the quantity, the volume, volumetric flow. And this CFH, you'll be familiar with it because it stands for cubic feet per hour, just like CFM, cubic feet per minute, in our air supply systems, right? Our HVAC equipment, right? Then BTU, still close to our HVAC too. BTU is British Thermal Unit. So it's a measure of the amount of energy, right? So that is this flow is referring to either the volume or the amount of energy, right? So then it also needs to deliver the correct pressure, and we use the safe materials with the safe measures and within the pressure limits, right? Because if it's too low, the system is not going to perform optimally. If it's too high, it could lead to like bursts and leakages and many other um, um, problems that could stem from it, right? So that is the pressure is too high, right? I mean, pressure drop means that as the longer the pipe, the lower the pressure is over the distance, right? So when it starts at the beginning, it's the highest pressure. So you have to select a pressure such that before the time it gets to the um, last branch or the last appliance, the pressure is still sufficient, right? So another thing we are talking about is the codes, right? So each of the designs from plumbing to drainage through to HVAC, they all have codes to be followed. In fact, there are so many codes. There's the building code, the plumbing code, the gas code, right? So let's just point out three important ones for this um, gas design, right? So we have the primary ones, which are the NFPA 54. Now I know that NFPA is going to be very familiar to you, right? So let's check the difference, right? So NFPA, even though they have the same acronym, it doesn't mean the same thing. So the one of 54 is for the National Fuel Gas Code, right? And the one of 72 is National Fire Alarm, right? So it's quite a coincidence, but it's important to understand there's a difference, right? So this one stands for IFGs. This one stands for International Fuel Gas Code, right? So this one is, as the name implies. Then California, for some reason, California likes to have their own thing separate, right? So usually there's like a national code, just like international building or mechanical code, and then each state, based on their circumstances, based on certain features that are local to them, they like to like make adjustment. For example, now there are certain locations that are like more prone to earthquakes or more prone to tsunamis, right? So the kind of codes or the kind of requirements you have is completely different, right? So also according to their needs, right? So California usually likes to take the extra mile to have their own code and stick to it, right? So you have CPC, and then you go to chapter 12. CPC stands for California Plumbing Code, right? So if you've noticed, there's a lot of similarity between our gas and water supply plumbing, right? I mean, after all, both of them have fluids flowing into them that are consumed by usage, right? So other codes that are related, not directly, but are related, like in extension, are the mechanical code, because it deals with combustion, air, and ventilation, right? Because I mean, as the gas is being used up, it's burnt, right? So the air needs to go somewhere, right? So you just need to like, if you want to get extra context on how that works, right? Then you have the fire code, which 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 is how the system is used to like how you can like manage systems to prevent fire outbreak, right? They also have the manufacturer instructions, very important, right? Because no matter how much the code is, codes were they were written by experienced professional engineers, right? But you see, the person that designed that particular connector or that particular component that you're using, it's important that you pay attention to what the person has to say, right? This is mostly for people that are installing on site. So you that is the designer, it's important that you understand how these things work. When you are designing, don't just like design blindly. Look up videos, look up pictures, research on what this thing looks like in real life, right? That if you can't have access to it physically, right? And then also check how, if there's any code, if there's any measure that you can put in place, right, to ensure that these things are done properly, right? And thankfully, right, the instructions are actually legally enforceable, because the person that manufactures is saying, okay, this is how it should be done. Even if the code says otherwise, most times there's always like an alignment, right? But if in any case there's no alignment, the manufacturer instruction is usually more superior, right, in most cases. So let's talk about the core concepts, right? So we have for you to memorize, right? So I mean, it's not a lot. you have the load, right? Each appliance has an input rating. This is just basically the amount of gas consumed by that equipment or by that appliance per hour, right? It's just the flow rate, right? The okay, I have even said talk about flow rate, right? So the load is just like that's pretty much it, right? So that means if you have three different examples here. So for a range, for example, the range, which is that kitchen, is the gas cooker, is it consumes 120,000 BTU at peak usage, right? So that means as you are listing out the different appliances you have, this is the load it comes with, right? So water heater is less, although some could be more. I mean, when you have to design a gas plumbing system for any project, you need to like, sometimes it comes with like a specification manual where you see like the different appliances and then their ratings. But if it doesn't come, there are some average values that you can select to design with, right? So then talk about flow rate, right? So the load is what the individual appliance consumes. The flow rate is ensuring that the right amount of gas goes to that device, right? And then we have the regulation to if it drops to like adjust accordingly, right? So the flow rate is like we mentioned before, is either in CFH or in BTU, right? CFH is the volumetric flow, cubic feet per hour, and then this one is energy, right? So you can see here that we have two major types of gases that are used in gas plumbing. There could be more, but these are the two that I know of, and mostly we will be focusing on is natural gas, right? So now this is the conversion rate, right? So for every 1 cubic feet of natural gas, you can get 1034 BTU in terms of energy. So this is like the energy density, right? So I mean, to now, for if your total maybe flow rate you need for your building is 240,000 BTU, kilo BTU, you do your conversion and you divide this by this and then you get this, right? So I mean, if you have your BTU, because most times your load comes in BTU, and then your when you're sizing your pipes is usually in CFH, right? So when it comes to BTU, you have to convert it to ensure that there's an alignment. Luckily, it's almost a whole number, right? So it's just to divide whatever the value is by 1034 and you get the CFH necessary. Then for propane, it's very similar too, only that propane has higher energy per cubic feet. So you can see that propane has higher energy density or is more dense in terms of energy than natural gas, right? So I mean, for this we need way less in terms of volume, right? You can see about 2.5 times, right? So moving on, we have the different pressure classes, right? This is still on that core concept. So many pressure classes is helps you to, just like how we have occupancy classification. So there are certain things that apply to the different pressure classes, right? So you have to like identify your building, which pressure class it falls under, right? And then that helps you to design better, right? So we have the lowest amount of pressure, right, which is really around 0.25 to 0.5 psi. Then we have medium, which is 2 to 5, right? Most buildings or most residential and light commercial projects fall under this low to medium, right? Generally I use 2, right, for average sized buildings, right? But as if the project is much larger or much smaller, I mean, you're going to see it, right? You would have to use this. For example, if in the entire project just one device or one appliance you're servicing, right? Or you can see from here, you can see the different levels. You can see some is up to the total of 240. So if, for example, now you have the load of just 40,000, you already know that that means it's going to be low pressure because you don't have a lot of things, like the pressure drop is going to be less, right? So you don't need to supply with too much pressure, right? So most buildings use low to medium pressure, right? So it's in rare occasions you have maybe industrial plants or larger project buildings that have high pressure, right? And it increases obviously with the number of appliances, the supply, the demand rather, right? So now let's learn how to size our gas pipes, right? So step by step. So this first step is to list the appliances and calculate total load as we've done here, right? Just as we've done here. So this plus is 120, total of 240, for example, right? So let's say that we have these three things in a building, right? So that means total load is going to be 240,000. So you have to list everything, right? you have to confirm. One of the things you do when you start a project, you have ask if there's gas on site. I mentioned this. I mentioned this sometime in our past video, on the past video, where, or even if I didn't, let me just mention it again. There are whenever I have gas on plan, right? Gas is generally cheaper, right, in terms of um the cost, right, per supply of gas, right? So if, but the thing is that it's not available everywhere. It's easier to access electricity than gas, right? And it also has its hazards in terms of fire outbreak. A lot of people are scared, even though the modern systems now have put a lot of things in place to make it safe to use, right? But it's generally safer than the setting up and the maintenance. Regular maintenance also is part of what can take up cost, right? But it's generally cheaper, right? So whenever you come across a project, you ask a valid question. A very important question to ask is if there's gas on site. You don't even have to ask, right? You don't even have to ask directly. You can look through the project. There should be something that points to the presence of gas on that site, right? It could be a site plan. Maybe you're looking at the site plan. Let me see if I have what the site plan looks like. um okay, let's quickly look at this. This is what the site plan looks like, right? So it's usually prepared by the civil engineer and architects, like it's a combined work, right? So it's usually very, like, there's a lot of information on it at every point, but it's usually very clustered, right? Very cluttered also. But it gives you an idea of like the surrounding of the building, because most times you just see the building plan, which is in this case now this is the building plan. They've called it out, right, by marking it, right? But this gives you an idea of like maybe the roads, the the distance away from the roads, then maybe other information, maybe the floor, type of ground, and I even mentioned I can even see something like point of access, right, for water and power. So this just means that if you are trying to like design water supply for this building, it's going to come from this direction, right? I mean, you're not always lucky to get the site plan or a detailed site plan, but if you do, it helps a lot, right? So let's look at another one. Yeah, let's see this one. So you see, this is a project. It just gives you like a bigger picture of the building, of the project, right? So you have concrete work, we have storage, right? A lot of important information. For example, I spoke about how sometimes some gas systems they use a tank, right? So in this plan like this, you might see such, right? So some important information, right, of what areas around that place looks like. So water fountain. Okay. So this is an outdoor covered kitchen, right? This is a project we're going to work on soon. And there's a property line. So this separates it from the next yard, right? So you can guide you, okay, this is where I'm going to set two certain designs for or from, right? So that's what you do. The next, you measure the longest length. I mean, this is very similar to plumbing, like water supply plumbing. So measure the longest length. The You would have seen, let's even look at a project. You would have seen the types of um okay, let's do this really quick, right? You would have seen the type of, okay, it's not here. Okay. I'm looking for a, it's okay. Let's just continue, right? So the measure the longest length, like we measured. So the distance away from the meter, water gas meter, right? The higher it is, the longer the distance, the higher the pressure drop, right? So that's why this is important, right? And so that you can size your pipe accordingly, right? Next, talk about you will now use the code sizing table. Right? So after these are like the two starting points, right? Then you now use our code sizing table. In this case, we're going to be using table 402.4 in bracket 11. Oh, this is not supposed to be metallic pipe. There's a mistake here. It's supposed to be, right. So let's look for this table, right? I already looked it up, so it's just a matter of finding it, right? Wait a little, right? Oh, it has not. Okay, yes, it is. Yeah, it is. Right. So now, are you serious? Let's try and connect and load this page, right? So the table, just like the table for water supply, also the table gives us an idea of, we have different materials, right? Let's say for it to come up, so we can, okay, it's coming up. There are different materials and there are different loads, different distances, right? So starting from the beginning. Okay, let's just see. I mean, you can read through all this like for more information, but that's what we're looking at for. Okay, these are the different tables. So it starts from one, which is metallic pipe, and you can see the type of gas, see the inlet pressure, the pressure drop, right, over the distance, not to the entire distance, right? It's unit pressure drop, right? Then this is how you now size the pipes accordingly. So these are like the capacity, cubic feet, like I mentioned, per hour, right? And then this is the length. So that's how we use like trace and find the right pipe to use, size of pipe. So you find maybe your total supply if is like maybe 300, you come to here, which is this, and then if the length, I mean, use both the length and the total load to calculate. For example, the length is maybe 80 feet, come here 300, so I go around here, right? So that means the main distribution pipe will be around 1/4. That's if you are using these details, like natural gas, because there's also place for propane gas too, right? There's natural gas, then these pressure levels, right? But most time we don't use pressure levels that are that low, so you see it's changing, right? So let's keep going. So there you can see as you are increasing, this number is changing, right? So we have gotten to a higher pressure drop, right? So let's keep going. Let's see what does this one, even higher, 3.5, right? I mean, we are still under natural gas too. So the one I'm going to like use to like do a lot of explanation is you can even see that the material has changed. It was initially metallic pipe at the beginning. So please, I would like you to go through this chapter, right? And get more information, read up more about it, right? So let's use this, right? So we've seen all of this already. This is a low, is less than 2 psi, so it's already a low pressure kind of situation, right? So we have two different types of the pipe. So please look up what these two things mean. So just check K and L of semi-rigid copper tubing, and then ACR. We're going to use K and L, right? So this is what it looks like, right? So yeah, that's the table we mostly work with, like for general projects. While if it's California, you check if California has its own corresponding table, right? Then next you size each branch and section. Now there's a document I use for doing this, right? A standard document called B703, right? Let me show you how. Okay, this is the document I was talking about, right? It's a standard document. Okay, this is the beginning, just a 2-page document. Let's quickly run through what it contains, right? So we have like this is a brief schematic of what gas plants or gas layout looks like, right? It's a schematic, right? Minimum information, but for you to understand, right? So this is the gas meter, this is the main distribution pipe, and these are branches off of it, right? um right, then we have the appliance name here, the BTU demand. Let's scroll to where we even have itself, the total length, and then the branch size, right? So we have total draw layout to use graphic below, right? So you can draw this in your when you're designing for a gas um, plumbing plan, right? You determine the BTU per hour, calculate the gas demand on each branch, right? So we are talking about each branch now. Start with the furthest appliance, right? And then add up the demand as you walk towards the meter, right? Okay, this is what it looks like. Right, so this is the appliance, this is the BTU demand, and the length, the maximum length to that point, right? Okay, not the maximum length, but the length up to that point, right? For the branch, this is at each branch, right? Then look what I mentioned earlier, how we have average values, right? If for any reason you don't have access to your specification sheet of your appliances, you can use these values, right? They're like standard values, right? But if you have, it's better to use that. This is in case you don't. This is like a last resort, right? You have a fireplace, 25,000 BTU. You have a range. You have clothes dryer, right? You have water heater. So of different um gallons, different volumes. This is tank water heater, right? So you can't use the same values for tankless, because tankless usually demands higher amount of gas, or it consumes more energy. That is why I generally don't like choosing tankless water heater, even though they are more like the provide water on demand, right? But the energy consumption is usually very high, right? Because you have to produce a lot of water within a short period of time, as opposed to tank that has produces it at a lower rate and then stores it, right? So yeah, let's quickly. This is the table, right? So this one is actually related. This document is actually directly related to CPC, the chapter 12 we spoke about earlier. That is California Plumbing Code, right? Okay, these are like some notes to take note of. Okay, yeah, this is just like how we had that sizing on this table. This is what the table for California looks like. You notice they've referenced where they got it from, right? You see the pipe sizes, you see the length, then you see the load, total load, right? So just to understand it, right? So, okay, you can see errors in the calculation. So there's a lot of disclaimer, a lot of warning for you to pay extra attention, right? So see the name here, prepared by this guy, right? A professional, obviously. So now this is an example, right, of how to size, right? So now we have one, two, three, four, six. We have six branches or six appliances being served by a gas plumbing system, right? So thankfully they all come with their BTU demand, right? So now let's observe, let's quickly study how this what all this information here is, right? So here you see this is a sign of diameter, right? So it means this is the main pipe diameter. The at the beginning is 1, then you see as it goes towards the end it reduces and gets to 3/4 here, 3/4 here. Fine, right? So now this is the distance. So it means from this gas meter to this first branch is 10 feet, right? Then from this branch to this branch is 20 feet. Now from this point where the branches of that main distribution pipe to where the appliance is 100 feet away. So that means when you're calculating for, when you are checking for the total load, you are going to take that entire distance, because the gas has to travel this 10 feet plus this 100 feet. That's why I have this 110 feet here, right? So same also here, it has to travel 10 feet, 20 feet, and then 5 feet. So that's how I have 35. So you add up everything and gives you 35, right? Then from here too, it travels 10, 20, 20, 20, that is 50, then extra 10 feet, which gives us 60, right? So it means that's why you have this is like table, right? You fill in all this information and then you use it to get your pipes. All this is just to get your pipe sizes, right? So you do that until this point, so that by the time you travel all additional distance, this distance is just from this branch to this branch, right? So you add it up, and then by the time you get to the last, you see that we have gotten to 145 feet, which is the longest distance as is stated here, right? To measure the longest length. Now let's get the total load from that, right? So now to get total load will be counting backwards. Measuring length is going forward, right? Farthest away from the gas meter. But now, in terms of load, it will be the highest at the closest point to the gas meter, because at this point, the gas here is serving this guy and everything ahead of it. But at this point, the gas is serving just this guy. So this is like the smallest amount, right? So to get the total, we get the one closest here, the farthest away from this, right? So now let's do it the reverse, right? So now we have the different BTU demands, right? So this one here is 65,000, so it stays, right? This we don't need to do anything here. This is the same information. It will have the same information as this guy, right? So now where it changes is at this point where we now have two branches off. So now you go back here. Now this is a point where there are two branches, the final branch and the one before it, right? So I mean the total demand at this point is the sum of this and this, which is 25,000 plus 65,000, and that gives us 125,000. Sorry, gives us 90. 25 plus 65, 90. This is 90,000, right? So this is in bracket is kilo BTU. That's why they took off the 1,000, right? So it's 90 is the sum of this. By the time you go back in this direction, you are adding the total demand from these two guys to this guy, because this guy, this at this point, at this junction, is supplying 1, 2, 3, right? Plus 35 to that 90, you get 125. You keep going on. As you keep going, get to this one that is even higher, 134,000. So when you add it to this existing, it increases and keeps increasing and increasing. So at the end of the day, the total demand is 369, right? So that means when you want to get your size, your main pipe, you're going to use 369 and the max distance, which is 145 feet, right? So now let's look at other information, which is now the branch size, right? So now you need branch sizes at every point, right? So for here, most times the branch size that is here is usually the same thing as here, right? Most times, right? And this one is when you get the total. For this case, you get your distance, which is 110, and you get your demand, which is 60,000, because you are sizing for the branch, not for this main pipe, right? That's why you see this is 3/4 and this one is 1. Is different, right? But if you're sizing along this, you want to size with respect to all the branches off of it, right? So let's look at this one now. This is 10 feet, 369. So at this distance, this is 10 feet away from the gas meter, right? And you have 369 because this is where all the junctions come to meet, right? So it's supplying everybody in front of it. So you go on and you check, you see that this one is taking only the distance. It's only looking at the main distribution pipe. So you have 10 feet here, 10 feet. So when you now add this one, when it goes forward to deliver to this guy, it has traveled another 20 feet. So that's a total of 10 plus 20, which is 30, right? So it gets to this point and it adds another 20, which is 50. So if you notice, the length we are getting along here is increasing, but increasing only in respect to the main distribution pipe, not the branches, right? When you include the branches, you are calculating for like the appliances, right? But by the time you are talking about only at this point, that's what gives you the sizing, pipe sizing. That's why at this point you see that since this one is supplying just 60,000, it has a smaller pipe, but this one is handling 369, so it has a larger pipe of 1 inch, right? It's only at this point, because as it goes further, the demand drops. At this point is where the pipe size drops, right, to this 3/4. And if you notice, the same for here and here, right? Then also yes, so this pipe size here is for this branch. It's for this branch. And if you notice, this one can increase or reduce depending on that individual branch demand, but this one just tapers, like it reduces progressively, right? So it's 1 1 1. So at the point where 1 is too large, it reduces to 3/4. I mean, if you continue reducing and maybe there's like a smaller thing to add here, it can even reduce to 1/2, right? So now let's look at, let's look at how they sized the sizes. This pipe is selected here, right? So now they've pointed at different points, which is A, B, C, D, E, right? So at different points, we're going to like size, right? So now let's size for point A, which is here, right? This is where the distribution pipe ends, and then the branch, this final branch starts, right? So now if more appliances were added, right, this line will just be extended. This is this portion, you just extend it and then add the extra appliance, right? But in this case, it is the last, right? So to have the same information as this B2. So now point B, here, the BTU demand is found by taking the larger value of the nameplate rating or the value shown in table A, right? So that is the total length. You check over, get the BTU demand for this, which is 65,000. The total length is 145, because that is the length that adds up to this point. Remember that sizing for this pipe is based on the amount of gas that flows from this point up to this point, right? So that's why we are using the total. Let's look at it, to be very honest, to be fair, the amount of gas needed here has to travel this distance. So that's why it needs to get that total distance of 145 as we have here, right? Now, to find the required branch size, enter the table below, rounding the distance from 145 to 150. So now this is the table we are using, right? So it has in increments of tens, right? So that means for this case we use 150 because there's no 145, so we just round it up to the next. So if you have 115, you use the rounded up to the upper estimate, right? And just like that, right? So now we take 150 and then we check the capacity of the pipe, the BTU demand, which is 92, right? So at this point is it 92? Is it 92? Okay, they've converted it from, in this case, 92 exceeds. Okay, yeah, is 92. That's for point B. Okay, point B. Okay. So we are looking for 65, which is what we have here. But now, when we trace this down, we have to select a value that is higher than 65 or equal to 65, which is 92 in this case. So 44 does not serve because it will be insufficient, right? 173 is too large. So just the next highest value, right? So that's what we use. So now we take this distance and take this demand, gas demand, and then trace it back. So it means the sizing at that point, the pipe for that point will be 3/4 inches, right? And that's why we have 3/4 here, 3/4 here, right? Now let's check for another point. Point C. Point C is saying in this case it serves as the range and fireplace, right? So now which is range and fireplace? Point C. Point C is this, right? So it means it's serving both this and this. So it means the total distance and the total demand will be different too. So let's check. Total distance at this point is from here. The total distance I'm calculated from here, which is 90, right? And then the total demand is 125, right? So let's check it. So okay, you can see here BTU demand is 90, 60 plus 25, because at that junction it's supplying two things. So that's why we have the total, right? Because when it drops to this guy, it moves on and gives another guy, right? Then total length is that's reduced. So as this one is increasing because it's going backwards, so that one will be reducing because it's going backwards too, right? So that means when you check, you now go to 125, which is this, and then 90, you go down to the point of 90, which is 102 is the closest point back. You have 3/4. So that's how you just continue, right, for the rest of it, right? I hope that was easy to understand. So you can check the other values from point D and E to for better understanding, right? So yeah, so that the sizing is done. So we're going to look at one example before we leave. So we have different materials that are used. We have semi-rigid, blah blah blah. Then now it's important that you avoid these types of pipe. I mean, most times you don't even have this problem, but if you ever see that somebody is suggesting, or you see like a case where they're selecting any of these types of pipe, it's a red flag. It shouldn't be used because they're not safe, right? They're designed for safety. So next, talk about how the gas system is integrated into the different equipments or appliances. We have the shut-off valve, like I've explained before. It is the main entry point. It should be placed at the main entry point, because if you need to shut off like the entire gas supply and then the individual appliances. So if the individual appliance needs like something you want to do there, shut it off at that point, or in case of an emergency, while the others keep receiving gas, right? Then you have the union or connector. As the name implies, it's used to connect, right? Just like how we have fittings, right? And then if you need to like maybe connect to points and then maybe release at one point, so that you have the different types of fittings, right? So you look them up. Then we have sediment trap, very important, right? This you may not show it on the design because it's very small, but it has a very important purpose, right? It is required for appliances like furnaces, water heaters, and boilers, right, to collect debris and moisture to preventing burner clogging, right? This is like a kind of safety measure, because gas is always usually flow with impurities if it's not very clean. Like there are different levels of purity, right? So particles, then moisture too. So that's why we have this is a leg, right? So the gas comes here, and before it gets into this thing, this is like where it gets trapped, right? Same here also. So it comes into this point, and then any heavy thing, because all these things are heavier, right? So the rest will rise, but this one it drops to the bottom, and with time it will be serviced, right? So it's usually placed like this, like you mentioned here. These are like the most important, because these ones they don't, if it affects the performance, if the purity of the gas is compromised, right, affects it, right? Then you have flexible connector. So flexible connector is used at the point where, okay, to connect rigid gas pipes. So we have the main pipes, right, and then we have the branches. But at that point where, okay, let's read it up, particularly for devices that need to be moved for cleaning. You know that the main pipes, solid pipes, are rigid, as you've seen here. You can, if there's vibration or there's moving, it can crack. So it's important to attach this just at the point of connection, so that if it vibrates during operation, it is designed for short localized connections. So it's not for like a long distance, it's just for that small connection. It's like a wire, so it has room for being flexible, right? So that it reduces chances of cracking or leakages due to shaking, right? So next, talk about more advanced topics. So these ones are beyond the scope of today's class, but it's important for you to just have an idea. So if you are designing for a larger project, right, regulators become even more important for each appliance. Then smaller pipe sizes are possible, right? Because as it travels down, the pipe size reduces way less, right? Compared to at the beginning of the piping. Then we have cases where not all appliances operate simultaneously. I mean, as I mentioned, the regulator helps with that. Then we have equivalent length, it increases, and with that, the pressure and flow changes also, right? Then we have future capacity. This one involves designing for growth. So when maybe you just design for, like, maybe it has phases coming up, or you know that there will be something added. But even if you don't know, there's how a project, you see a project, you just know that you have to add like a factor of safety in case there's something added, so that the system can still cater for it, right? So these are some mistakes to look out for, like I've already mentioned earlier. Right, just scan through this. So that is the end of the class. So let's quickly look at a project before we call it a day. Let me even check how many minutes we spent first. Okay, let's look at this project real quick, right? So to save time, I've already like shown you the layout, right? So I mean, you understand how all of this works. So we have just 3 appliances on this, right? So so this is where our layout comes from, right? This is our gas meter, right? Because we got from the site plan that this is where the gas line runs, so it was important and expected to connect it from this point, right? So we have, just like in freshwater plumbing supply, so we have our backflow preventer to prevent gas from flowing back. Then we have our meter as necessary. So now we have our pipe sizes. We'll look at this shortly. So this supplies to this point, right? There's a range here. When you go forward, there's another. Let's even check what this is, right? Okay, we have the burner, which is like a range. Then we have, is the closest to the gas meter. We have the grill. We have the fire pit, right? So let's do that. I mean, the major thing is sizing, right? Sizing. So we have a fire pit here. So I mean, this is the farthest point away. So if you want to get, you have to measure your distance up until this point. Let's measure that distance sharp, sharp. I mean, you already know how to do it, but let's just do it. Let me just give you an idea. So this is how it works. Okay, measure this 31 feet, for example. So you do that for all of them to get your total distance, right? Right. Now, let's go to, what does page 2? Okay, G3. Okay, let's go to G1 first. Let's see what does G1 hold for us, right? Okay, I use the G1 is just the notes, right? The plumbing note, gas notes, right? And then the index, the codes used. Like I mentioned, it's better to specify, right? Then G2, this is the different pages. Oh, perfect. So G2 shows just that portion of the design, right? So it's visible here. I mean, if you try to print it out, the output. This color is not showing like this. I know I've shown you how to do it before, but let's look at it again. So just plot. So you try to print it. I mean, we've never really printed. I think we've set up all of this. So you have grayscale. Grayscale makes it shows between black, gray, and white, right? So then we have the at full bleed, which is the paper size. So let's preview what it looks like. Okay, you see now that it is gray, and gray is for the background, things that we don't want to stand out, but the other ones are in black, right? Black, and then we have the gas line too, right? So yeah, escape, and escape again. So now let's go to how the sizing of these pipes. Okay, these are some gas piping notes, and then this is just the key plan or the keynotes. Let's quickly go to, okay, so this is what this is a riser diagram, right? So it just shows us a brief of what our gas supply layout looks like, right? A schematic. So I mean, if you notice, this is an outdoor system. From what you can see here, it's outdoor, right? So this is the main building, but we are not dealing with the building. This is outside, so this is an open air kitchen, right? So, and then this is an open air this too. So it's mostly outside, so it makes sense that we are connecting underground, right? So our gas is going to travel underground. So that's why we have this. So it's coming from the city gas line, and then these are the sizes, right? So okay, now this is the part that we want to look at before we leave for the day. So we have, this is what we use semi-rigid copper key and L at under 2 psi for inlet pressure, that is the pressure at this point. And then because we selected it because we have fewer appliances, and that means that the demand will be low too. Let's even see the total demand. Total demand is 25 plus 50. Okay, you see it here, 115. That is quite low. Like, maybe it was larger, maybe up to 300, 400. Then we can take on like larger pressure, right? So let's look at that table again. Okay, this is where the table is. So this is what we are using, less than 2 psi, 17, right, in terms of pressure drop. So now let's get our total length and our total demand, maximum demand, which you've seen here. Total demand, because we've added up everything up until this point. So at this point is where the largest demand is. Then the total length is measured in this distance, so it's 69 feet, because the distance from the gas meter to the first appliance, right, is 12 feet. Then the distance for this appliance, the branch itself, not the appliance, because as you've seen here, we have the main distribution pipe, which is this. Then we have each branch, so each branch branches off at this point. Now we now have another distance it travels, right? In some cases this is a short distance, but this is a good example because it is relatively long, right? So that is what that distance is. Yes, which is 4 feet, which is the distance of that branch. So it's also the same thing here, 4 feet. Now this last one is the entire distance it travels from this branch to this last point, right? So now sizing this, as you said before, let's start from this point, right? So we see total distance is 69, and then the gas supply is 25,000. Now this 25,000 is in BTU. Remember, we need to size in CFH, because that's what the table carries, right? CFH. So let's check. Let's quickly yes, let's calculator. So you divide it by, this is natural gas, so you divide it by 1034. So 25,000 divided by 1034, right, equals to 24. So that is our, is it 24? No, it's not 24. It's not 24 we are using. We are using the maximum sizing for this point, right? So it gets confusing, but you need to like take your time and understand it well. Let's go back to that our document, because sometimes it confuses me too, right? So sizing at this point A, you are taking the total length and then the demand at that point, which is 65. So I mean, so that means in this case it's 25. We got it right, and total length. So this is what we are using to size 25, which is 24. We've gotten from this calculation that has dropped to 24, right? 24. So we look for 24 and then at 69 feet. Let's check our table. Right, 24. So it will be somewhere here in terms of length, and then 65 it falls here. So that's why we have 1 over 4. Right, so this is the size we are selecting, 1 over 4. Right, that's what we have here, 1 over 4. So now we move on to this one. I want to check for this one. So in this case, we check the total length, which is 24 feet, and then the grill, the demand at this point. So if you remember, this pipe are sizing 7 only this. Don't be confused, 7 only this. So we use just the amount of gas traveling here, which is 50,000, and then the total distance, right? This distance, remember, is sum of all of these, 12 plus 8 plus 4, right? That's why it's important. It's really important to fill out these boxes first, right, before you start selecting the sizes, so that you just have to take it so it doesn't get confusing. So we filled all of this out. So we know this, we know this. So let's check 50,000 at 24 feet. So 50,000 will divide it by 50,000. It should be somewhere 50,000 divided by 1034. That would be equals to 48. So we check 48 at 24 feet. Right, 48. Okay, 24 feet. Oh, I made a mistake. 69 feet. It's 69 feet we had before. 69 feet. Although it doesn't change much. 69 feet is 70 we'll use. 70, right, at 25. So we still used. Okay, let's just, let me not confuse you. Right. Let's go back to this. So I made a mistake here. Right. So we used 25,000, which is 24 when we divided it, and 69 feet. Don't get confused. So 69 feet is 70 at 70, right? Because this is the largest, the closest larger value, and then 24. So 24 still falls under 66. If it was 67 and above, would have gone to the next column, which would have been 3 over 8, but still falls under your size 1 over 4. So please, let's not get it wrong, right? So for the next guy, okay, for the next guy, it is 50,000, which when divided it became 48, right, and then 24 feet. So let's check 50,000, 24 feet, 24 feet, that will be somewhere here, then 50 to 48 rather, still falls under here, right? So I mean, so it falls here. So this one, when you have found the distance, you check in this direction, not down, check in the direction. So this is the smallest, closest, right? So that's 50,000. So see, use 1 over 4. So in this case, virtually all of them used 1 over 4 because the values are close to each other. But when you have larger, the next project we'll design, we'll have larger demand, so the values will be changing. Right, so 1 over 4. So now let's try to size for that is for the branch pipes. Right, so we check for this one. So that'll be 40,000, which is about 30 something. If you divide it by 1,034 and 16, it will still give you 1 over 4. Now let's size for this main pipe, this point, right? So let's see, okay, at this point, let's say for this point now, the pipe at this area, right? So we'll take the total demand and total length. Length is smaller here. In this case, it is larger, but here this is smaller because it's just 12 feet. So we take 12 and 115. So 115 is 115,000. So let's divide it. 115,000. 1,5,1,2,3 divided by 1034, right, equals to 111. Right, so you take 111, 111 in demand and take in length, total length 12. Usually start with the length, 12 feet. So you come here, 12 feet will be somewhere around, it's just above 10, which is 20. So with this, so 111 falls on that day. So we still take 1 over 4, right? So that's just how we size for all these points. So at first, when you just copy, you know how this is. That's how all this will be empty. These tables will be empty. So then you fill it in, the name, the demand, the length. You have to measure for the length, right? But these first two, you can fill it in to start with. This one, you won't have any information to start measuring. So you come here, you go to your design. Okay, let's even do it. So you have, this is 12 feet. Let's go and check. right, from the gas meter to the first um from the gas meter to the first appliance. So let's say home, measure, right? And remember, there are different types of measuring, right? So there's align, there's linear, there's angular, depending on what you're measuring, right? So let's see if this works for what we want, right? So to this first point, which is here, that is the point where the branch takes place, right? So okay, you see, this is not what we want. This is giving us only in vertical. This is even a very good project to describe this, because this doesn't give us, okay, it gives us only in vertical and horizontal. Right? This is not what we're looking for. We need this guy aligned. Aligned means it follows the line, right? So this line is inclined at an angle. So okay, perfect. This is exactly what we need. So you see that it is 11 feet 8 inches, which is approximately 12 feet, right? But what thing I usually do is that when I get distances like this, if I approximated this one up by 4 inches, the next one, if I see that there's extra maybe, okay, let me show you what I mean. If I see that maybe it will mostly never be in round figures. So now you see this one has now added up to 7 8, right? So by the time you get to the next one, maybe another one is somewhere here. Now you see that you can't just always be doing, if you keep adding, this man is now becomes 8, this one becomes 12. If you keep adding it, it might end up being longer than the actual pipe, because you are approximating upward. So what I do is that whenever I have a case where maybe it's less, maybe you have 7 feet and maybe 1 or 2 inches, I round it down to make up for the one I rounded up before. So at every point in time, I'm like making sure that I'm balancing out the sizes, right? So okay, the main pipe size, oh, this should be 1/4. Yeah, thank God we saw it. 1/4. So 1/4, right? I mean, for all of them, this was right 1/4, because we've confirmed that every pipe we used is 1/4. 1/4 space. Okay, so yeah, so that is pretty much how it goes. So you measure that distance and then you come and fill it in here. The first one is 12 feet, and then you measure this distance, right? It's 4 feet. That I have 16 here. So you keep going. This one is now 8 feet away. So 12 plus 8 is 20, plus 4, 24, right? So when you measure along this distance, you made the main pipe, you put your value here. But if you take it down into the branch, the appliance itself, put it here, right? This helps in sizing, because if you're sizing at this point, you're sizing for this point, you're sizing this distance up to this point. But if you're sizing for this point, the pipe itself, the main pipe, you're sizing for just this distance, right? So yeah, that's just everything we need to know, right? So you would see if you can design another project, right? So I've not printed out for you before. Let's do that today. So output, oh, we have a lot. We have other projects I'm working on currently, but let's see what I can do regarding output. So batch plot, I don't know if you probably don't know about this. Let's just look at it, right? So batch plot is the way of, you can print page by page. That is what plot is for, right? So we want to print just this page, you use plot. But if you want to print like pages that are aligned, just you see here, you see that it's G1, G2, G3. So it's like pages of a document. So we want to print out that entire document, right? So how do we do that? So initially you would have already previewed each page. You try printing out each page and preview it, right? I don't need all this, right? So you delete all of them, all the pages that I don't need. What I need is just this guy. No, I made a mistake. How did I even get here? Okay, so you select, okay, go up. So you delete the one that we don't need. Okay, this is what you are left with, the last two. Made a mistake. So you say no, right? Let's try that again. All that, right? So that is how it works, right? So you want to print out these 3 pages, for example, right? Okay, let's do that again. So I have some things already there, and I don't need all of them. I need just, okay. So this is our model. You can see that all the pages we have here are the pages we have here. So you delete the model because you don't want that. You just want the pages. So this guy too, right? delete it. Okay, should be one of the pages. Just leave it. We'll check what it is after because I don't want to go back. Then we publish it, right? Ask you where you want to publish it. Go to desktop, go to this, go to folder for this, and you select the gas plumbing. Okay. Okay, so this generates PDF. Select it. No, you don't want shit, right? So it takes a bit of time depending on how fast your laptop is, right? And then it's loading currently. So let's check what our final product looks like. Okay. Okay. So this is what it looks like. This is our first notes page. Then we go to the next page. Shows us our layout. Clean because black and white, and then green is very visible. Okay, right. Then we go to the next one. Then it just shows us, oh, mistake, shows us this information, the gas sizing, the pipe sizing, and then you write that diagram, right? You write that layout rather. So this is what it looks like, right? So I mean, obviously, as you design more and you get more experience, you're going to like add more information, such as notes, like all those things I was telling you, sharing with you earlier in this place. All these things that I did not show, add it in the notes, right? Add it in the notes. You may think that the note is plenty and too bulky, but people actually read it, right? Read it and then to ensure that they don't make mistake in installation or in designing, or in not the designing, installation mostly, right? Because if they do something different from what you said, you can prove that okay, I had it in the document, but you did not do it accordingly, so it vindicates you, right, in case there's any problem later. So thank you for showing up today, and we'll have another class soon.